Assalamu alaikum everyone. So today we are going to start AS level chemistry paper 2. It's 970122 and it's a February March 2025. Okay. So let's move to question number 1. Phosphorus and chlorine are the elements in period 3 of the periodic table. Chlorine forms 3 different compounds with phosphorus. The most common compounds are PCl3 and PCl5. Complete table 1.1. Okay. So they are asking for the oxidation number of phosphorus and the oxidation number of chlorine. So if you see, chlorine is in group 7, so it usually has an oxidation number of -1. So this chlorine has an oxidation number of -1. And this chlorine also has an oxidation number of -1, right? And as there are 3 chlorines over here, so -1 times 3, and the net charge is 0, so this one goes +3. And over here, -1 times 5. So the net charge is 0. So this one goes +5. Is this understandable to all of you? Okay. Now, part 2. In a closed system, PCl3 and PCl5 exist in equilibrium mixture as shown in reaction 1. So here is a reaction 1, and here you are provided with the equation of the reaction 1, and they have also provided you the enthalpy change, which is in negative, indicating that the reaction is exothermic. Deduce 2 conditions that favor the production of PCl5 in reaction 1. So one condition would be lower temperature, because lowering the temperature shifts the equilibrium towards exothermic side, and higher temperature shifts the equilibrium towards endothermic side. So the forward reaction is exothermic. It means we are going to lower the temperature. Further, we have 1 mole of gas on the reactant side and no gas on the product side. So the product side has a lesser mole. So increasing pressure shifts the equilibrium towards the side which has a lesser moles of the gas. So we can use high pressure and low temperature to increase the yield or the production of PCl5. I hope it's clear to all of you. Now, question number 1A, part 3. The third compound of phosphorus and chlorine, W, has a relative molecular mass MR between that of PCl3 and PCl5. Okay. The compound contains 69.6% of chlorine. Determine the molecular formula of W. Okay. So they are asking for the molecular formula of W. Okay. So you can calculate the percent of phosphorus. So to calculate the percentage of phosphorus, we have to subtract the percentage of chlorine from the phosphorus. It is going to be 100 minus 69.6, which is going to be equals to
30.4.
30.4. So we got the percentage of phosphorus, right? Now we are going to calculate its empirical formula with the help of mole ratio. So we know phosphorus and chlorine. So the phosphorus is 30.4 and the chlorine is 69.6. What we are going to do, we are going to divide with their AR values. So the AR of phosphorus is 31 and the AR of chlorine is 35.5. Can anyone divide them and tell me the value, please?
Sir, Chlorine is 1.96
1.96.
and phosphorus is 0.980.
0.980.
So 1:2.
Yeah, so the ratio is going to be 1:2. And if the ratio is 1:2, so it is going to be PCl2. So if we calculate the mass of PCl2, so the mass of PCl2 is going to be 31 plus 35.5 times 2, which is equals to 102, right? Because it is going to be 71 and 31 is going to be 102. Now, if you calculate the MR of PCl3, so the MR of PCl3 is 137.5 and the MR of PCl5, so 5 chlorine. So what is the MR of 5 PCl5? So it is 35.5 times 5, which is going to be 142.
208.5.
208.5. Okay. So it means that's it's MR as they have told you in between these two. So if I do it times 2, it is going to be 204, right? Which is the middle value of these two. So if I'm going to make it times 2, so it means that PCl2 times 2, so it is going to be P2Cl4. So the molecular formula is going to be P2Cl4. Is this clear to all of you? Yes.
Yes, sir.
Okay. Now, part 4. W is a liquid at room temperature and pressure. It reacts vigorously with water to form an acidic solution. So this is the structure and bonding in W. Explain your answer. So, the structure, it's a liquid, right? And reacts vigorously. So it's a simple molecule as its melting point is low. There are covalent bonds as it hydrolyzed, right? Reacts with the water is a hydrolysis. So if it reacts with the water, that is a hydrolysis and has a low room temperature. If it's a liquid or a gas, so it has a low melting point, which indicates it's a simple molecular structure. Okay. Now, B part. Figure 1.1 shows a reaction scheme involving P4 and chlorine. Okay. Just give me a minute. I think, yeah, there is something missing in it. Let me check what is missing. Yes, it's opening. Let me check it. Okay. So yes, we have a P4 reacting this, P4 reacting over here, PCl5 turning into B, then PCl5 turning into this, and A is turning into this. Okay, so this is the reaction scheme. Okay, now, so just what is observed in reaction 2? So if you see in reaction 2, phosphorus is reacting with chlorine, and as a result, PCl5 forms. So the reaction is with the chlorine, right? And the chlorine is a green gas, and when it forms, there is no chlorine over there. All the chlorine is being used up. So we will answer that green gas disappear. Now next part. Predict the shape of the molecule of PCl5. So phosphorus, if you see, phosphorus has 5 chlorines, and there are 5 bond pairs and no lone pairs. So it's a trigonal bipyramidal. Trigonal bipyramidal. Next, write an equation for the formation of A in reaction 3. So with the oxygen, it is forming A, and you have to write this equation. So it means P4, when reacts with oxygen, it will form phosphorus oxide, and the formula of phosphorus oxide is P4O10, right? So to balance the equation, we need to put a 5 over here. Our equation is balanced. Now, name B, which is formed in both reaction 4 and 5. So when PCl reacts with water and when phosphorus acid reacts with water. So in both the cases, phosphorus has a +5 oxidation number over here. Over here, it will become P4O10, where the phosphorus is +5. Over here, phosphorus is +5. So when they both react with water, they are going to form acid, phosphoric acid. So B is going to be phosphoric acid, H3PO4. Now next part. Draw the structure of C used in reaction 6. So if you see, we are getting the chlorine both sides, and with the PCl5 only organic compound alcohol reacts. So it means that C is an alcohol having a 2 carbon, and both carbons are bonded to OH. So C, you are going to repeat the same structure, but instead of Cl, you are going to put a OH on both the sides. So that is the structure of C. So the OH gets displaced, right, with the chlorines. Now, C part, 1,2 dichloroethane reacts with sodium hydroxide to produce an unsaturated compound, C2H3Cl, shown as shown in reaction 7. So here we have a reaction 7. State what is meant by unsaturated. So the unsaturated, which contains one or more carbon-carbon double bond. So a compound which contains carbon-carbon double bond. So better to write which contains one or more carbon-carbon double bond. And if there is a carbon-carbon triple bond, that is also considered as unsaturated compound. State the conditions for reaction 7. So in reaction 7, as it's an elimination reaction, so if you see what is the structure, it is going to be actually CH2 double bond CHCl, and it is actually CH2 CH2 Cl Cl. So the chlorine from the left and one hydrogen from here are eliminated, and we will get double bond. So whenever the halogen oil can undergo elimination reaction, the conditions are, if you remember, that we use heat sodium hydroxide in ethanol. So we are going to use ethanol as solvent, and heater. Now, part D. Compound D contains a carbon, hydrogen, and chlorine only. Figure 1.2 shows the mass spectrum of compound D. Oh no, it is master.
सर बीस जीत में से नसेंगे
Sorry,
सर इसमें 20 जीत में से नसेंगे 330 नसेंगे
I didn't understand what you were saying. Laiba. To see, here we have this. Okay, now explain the relative abundances of peak 1 and peak 2 in the mass spectrum of figure 1.2. Okay, just 1 minute, please. Yes, so they are asking for the relative abundance of peak 1 and peak 2. So if you see, peak 1 is 100, right? And if you go for peak 2, it's over here. So there is 100, and if you see, it's around considered to be 33.3. So their ratio is going to be 100 is to 33. So if you 0.3, so if you simplify it, it is going to be 3:1. Is this clear to all of you? Now they are asking for the structure of D. So see, basically peak 1 is M peak and peak 2 is M plus 2 peak. And they both has a ratio of 3:1, which is due to the chlorine 37 isotope, chlorine 35 and chlorine 37 isotope. So it is due to the chlorine 35, and this one is due to the chlorine 37. That's what we have studied when we getting the M peak and the M plus 1, M plus 2 peak in the ratio of 3:1, indicating the chlorine. Okay. So we got its MR is 60, right? So it is, for example, we have our two carbons. So what is their MR? Mass is going to be 24. Then if we have one hydrogen. So 25 plus 1 is going to be 24 plus 1 is going to be 35. Oh, sorry, 25, and then chlorine. So if it's 35, so it is going to be 60. So it is going to be C2HCl. Or if in this case, see, there are two carbons, and we know each carbon makes four bonds, and there are two more atoms. So it means there is a triple bond between the two carbon atom. One carbon is bonded to a chlorine, and the other carbon is bonded to the hydrogen. So that is the structure of D. Is this clear to all of you? Yes. Okay. Now question number 2. Group 2 elements show metallic bond. Define metallic bonding. So I'm not going to write the definition. You must remember that it is an electrostatic force of attraction which holds the cations and the delocalized electron, or it is the electrostatic forces of attraction between the cations and the delocalized electrons, right? Next part, group 2 elements form stable to positive ion state and explain the variation in the ionic radius of the group 2 elements down the group. So we know what happens to the atomic radius down the group ionic radius, it increases, right? Or gets larger. And why is it so? As the number of shells increases. Okay. Now, table 2.1 shows successive ionization energy values for beryllium. That is the first element in the group 2. Use table 2.1 to state and explain the general trend in these values, the significance of the large difference between the second and third ionization energy. So if you see the general trend, the general trend is generally ionization energy increases. It is increasing actually, right? As shielding decreases, because as you remove the shell, the next shell electrons which we are going to remove are going to be removed from the inner shell. So as the electron moving towards the inner shell, so there are lesser shells between the electron and the nucleus. So it results in the decrease in shielding. So as shielding decreases, okay, it's for 2 marks. So we just got 1 mark. Now, second and third. So the large jump between second and third ionization energy, indicating that third electron is removed from inner shell. Is this clear to all of you? Now C part. All group 2 elements except beryllium have more than one stable isotopes. Beryllium exists as a single isotope, okay, with the B beryllium 4. Describe the distribution of mass within the atom of beryllium. So mass is due to the nucleon and proton, right? And that nucleon and protons and the nucleons are in the center, are in the nucleus. So almost all the mass is due to proton, and neutron, collectively called nucleons. Protons and neutrons present in center, that is nucleus. Electrons have negligible mass because their mass is 1,300 and 1,738 times lesser than the mass of proton. And it orbits around the nucleus. Now, part 2, complete table 2.2 to show the number of protons and neutrons in the isotopes of magnesium. Okay, so if it's magnesium 24, okay, if you look for a magnesium in the periodic table, you will find that magnesium's atomic number is 12. So the number of proton are going to be 12 in all of the cases. And that 24 is the sum of protons and neutrons. So if there are 12 protons, so the neutron are also going to be 12. 25, so 12 protons are there, so the neutrons are going to be 13. 26, so there are 12 protons, so there are 14 neutrons. Okay. Now figure 2.1 shows the behavior of a beam of proton in an electric field. Complete figure 2.1 to show the behavior of a separate beam of neutron and electrons in the same electric field. Label your diagram clearly. Assume that the beam of each particle are moving at the same velocity. Okay, so if they are moving at the same velocity, we are going to draw at the same distance. So beam of neutron, as neutron is neutral, so it is going to be straight. Right? And protons are going to be, obviously, when the beam of proton is moving upward, so the beam of electron is going to be moved downward, and electrons are lighter. So it travels, it bends more than the proton towards the positive terminal. So for a proton, we are going to show a bigger angle, bigger deviation. So I'm going to label it beam of neutron, and over here, beam of electron, neutrons and electrons. I hope it's clear to all of you. Now, D1. State what is observed when dilute hydrochloric acid is added to a separate samples of barium oxide and barium carbonate. So with barium oxide, metal oxide reacts from salt and water. So barium oxide is a solid. So what is going to happen? That solid disappears. And barium carbonate is a metal carbonate, and metal carbonate when reacts with the acid, they are from salt, water, and carbon dioxide. So over here, as it's a solid, so one thing that we see, the effervescence, and there's a solid barium carbonate, so that solid also going to be disappear. Now, to write an equation for the reaction of strontium with an excess of cold water. So remember, when a metal reacts with the cold water, it will form metal hydroxide. So they are asking for the reaction of strontium with the water. So when strontium and water reacts, you will get strontium hydroxide. Strontium has a +2 charge, hydroxide has a -1 charge. So the formula would be SrOH twice. And to balance the equation, and beside this, a hydrogen gas is formed. So we need to balance it by putting the 2 over here. Now it is balanced. Now, third, state the variation in the solubility of group 2 sulfates down the group. So remember the solubility decreases for the group 2 sulfate. Yes, very good, Laiba. Decreases down the group. For the hydroxides, their solubility increases down the group. Okay. Now we are moving towards question number 3. The halogen, chlorine, bromine, and iodine shows trend in the chemical and physical properties down the group. Table 3.1 shows some properties of chlorine, bromine, and iodine. Okay. Complete table 3.1. So they have mentioned for chlorine that it's a green gas, so bromine, if you remember that it's a brown liquid, right? And for iodine, it's a gray black solid. Now, next part. The bond energy values in table 3.1. Okay, over here. Refers to halogen bond where X is the halogen. Okay. Explain the trend in the bond strength of the halogen bond in halogen. So it means they are actually asking, there is a halogen bond between the chlorine, there is a halogen bond between bromine, and there is a halogen bond between iodine atoms. So what is the strength of this bond? So when we move down, the size increases, so the bond gets weaker, right? So down the group, the size of atom increases. So as a result, we got the increased bond length and bond gets weaker due to lesser attraction. Now, explain with the use of an equation how chlorine used in water purification state the role of the active species around. So if you react the reaction of a chlorine with water, when chlorine reacts with the water, it forms HCl and HClO. And HClO dissolves in water to form ClO negative. So that ClO negative kills bacteria in water. ClO negative. Now, the sodium halide in table 3.1 shows the trend in the chemical properties. Okay, their electronegativity, right? Identify sodium halide that reacts with the concentrated sulfuric acid to form H2S. So if you recall, only the sodium iodide is the one, because iodide reduces sulfur in the sulfuric acid to -2 in H2S. With bromine, it will form just SO2. With chlorine, we have got just HCl and the salt. No other redox reaction occur. Now, identify the sodium halide that only undergoes a Prostad-Lowry acid-base reaction with a concentrated sulfuric acid. So it's the chlorine. So sodium chloride, because it doesn't react uh, with the sulfuric acid a redox reaction, but just do the acid-base reaction. These are the all equations are present in the notes. A student adds few drops of silver nitrate to a solution of sodium bromide state, what is observed? So we know that with sodium bromide, when silver nitrate is added, we will get green precipitate, and if there is a iodide, we will get the yellow precipitate, and if there is a chloride, we will get the white precipitates. Now part D. Iodine monobromide IBr is a dark red solid that melts near room temperature. Okay. IBr reacts with propene. The mechanism for this reaction is same as the mechanism for the HBr with propene. Okay. Identify all intermolecular forces that exist between the IBr molecule. So if you see IBr molecule, there is an electronegativity difference. Iodine is going to be partial positive and the bromine is going to be partial negative. So due to these dipole, there is permanent dipole dipole forces, and remember in a molecule where there is a permanent dipole forces in these molecules, induced dipole instantaneous dipole forces. Instantaneous dipole. Now next part. Name the mechanism involved in the reaction of IBr3 with propene. So if you recall, alkenes undergo electrophilic addition reaction. So this is an electrophilic addition reaction. Okay. Now, the reaction of IBr with the propene forms two structural isomers. Draw the structural isomers shown by these molecules. So, see, it's a propene. So, CH3, CH, double bond CH2. So, one possibility is this, it turns into single bond, one iodine get here, bromine get here. The other possibility is opposite to it. So, now iodine gets to the brominal carbon and bromine in the middle one. So, see, here are two isomers. Okay. Now, next part, identify the type of structural isomerism shown by the molecules in D3. So if you see their positions are being changed. In one polymer isotope, isomer, bromine is at a first carbon and then the other one it's a second carbon. So these are position isomers. Explain why the two structural isomers do not form in equal amount. Because if you see, uh, we know that the intermediate carbocation are different, right? So bromine is more electronegative. So the intermediate carbocations form. So there are intermediate carbocations formed. So one is primary and secondary. Further, I'm going to add secondary is more stable due to more alkyl
सर ये
groups.
दोबारा बता देंगे, समझ नहीं आया.
1 minute. Causing positive inductive effect. See, if you look at the above chart, the electronegativity of bromine is 2.8 and the iodine is 2.5, right? So it means iodine is less electronegative and bromine is more electronegative. So when the compound forms, iodine is going to be positive and bromide is going to be negative, right?
Yes.
So when the reaction occurs, the bond break in this way, making iodine a positively charged, which is directly bonded to the carbon and the bromide forms. Is this clear?
Yes.
Okay. Now if you see, this is actually made from this one, CH3CH double bond CH2. So in one case, we got the positive carbocation over here, and the other case would be the carbocation over here. But if you see, this one is the secondary carbocation and this one is a primary carbocation. So this carbocation is more stable. So it means more quantity of the secondary carbocation is formed as compared to the primary carbocation. So that's why we would not get the equal amounts. And why is it so? Because this secondary carbocation is more stable due to it is bonded to a more alkyl groups causing more positive inductive effect. Is this clear?
Yes, sir.
Okay. Now question number 4. Figure 4.1 shows compound J2M, each of which contains 4 carbons. Okay. So if you see, the first one is an acid, third one is a secondary alcohol. No, first one is an aldehyde. So 1, 2, 3. Okay, it's just like this. So it's a ketone, it's an alcohol, and it's a carboxylic acid, right? Okay. Table 4.1 gives details of tests on J2M. In each test, only 2 compounds give a positive result. Complete table 4.1. Compounds that get for okay. So when the positive test is with dichromate, so we are going to observe the color change from
Orange to green.
yes, very good. Solution color changes from orange to green. With aqueous iodide, yellow precipitate. Okay, so these two tests are been positive by J and L both. No, actually it is like this. So we have to identify the yellow. So the yellow precipitate aqueous alkaline iodine can be done by if it's an aldehyde or ketone forming CH3
AL.
bond O. And for alcohols, if alcohol has a CH3, C bonded to NH and OH. So if these two structures are there, so if you see K has this structure, and if you see L has this structure. So otherwise no other compound has these two structure. So we have identified that yellow precipitates are due to K and L. Is this clear? Okay, J and K are giving
हाइड
the
नहीं कर सकता.
sorry.
सर एल्डिहाइड भी तो करेगा
No,
आयोडोफॉर्म के साथ.
no, aldehyde only this aldehyde having this group, not all other aldehydes. Okay.
ओके सर.
Okay. Now with the orange precipitate, J and K both are aldehyde and ketone. So the orange precipitate, aldehyde and ketone are formed with the reaction with 2,4-D and
4
BH. Okay. With sodium carboxylic acid and alcohol react. So it means this and this is going to be react. So over here, a hydrogen gas is formed. So either we can write effervescence
और bubble?
You can write bubbling. And they are L and M because L is also reacts with sodium and the M carboxylic acid also reacts with sodium. Till here, is this clear to all of you?
Yes, sir.
Okay. Okay, we are done with the paper. So over here again, it's some errors in the formatting. K reacts with HCN in the presence of KCN, catalyst forming N. So it means if KCN is a catalyst, so it means K can be either aldehyde or ketone because this reaction where HCN is a reactant and KCN is a catalyst is the one in which the aldehydes and ketones are involved. Complete figure 4.2 show the mechanism for this reaction. Okay, so if you recall, it got the negative charge. This one is partial positive, this one is partial negative from the lone pair attacks on this carbon and this bond broken down easily, forming you the intermediate. Oh, 1 minute. So we are going to get this. And from this lone pair, it attacks another HCN molecule, from which the cyanide ion is restored as a catalyst. So we'll get a cyanide ion as well. Is this clear to all of you? Now,
Yes, sir.
part 2, identify the class of compounds of which N is a member. So if you see N has OH and C in both, so these compounds are called hydroxynitriles. Now, N has a chiral carbon. Explain what is meant by the chiral carbon. So a carbon which is bonded to 4 different groups. Bonded to 4. So any carbon which is bonded to 4 different groups is called a chiral carbon. Okay. So over here we have done with the whole February, March 2025. Now we will do the next paper in the next class, which will be held tomorrow. Any questions from today's class, please ask.
सर वो जो बॉन्ड स्ट्रेंथ वाला क्वेश्चन था वो एक दफा दिखाइएगा.
This one?